12.3a is inscribed angles, okay? My favorite, inscribed angles. An inscribed angle, okay? We've talked about like a circle inscribed in a triangle or a triangle inscribed in a circle, right? It fits perfectly inside. This is an angle that fits beautifully inside of a circle. So an inscribed angle, your vertex is on the circle, and then it's formed by two chords to that circle. So the red lines here, AC and BC, those are chords of the circle. So our inscribed angle is this angle. Notice the vertex is a point that's on the circle. Okay, that's an inscribed angle. An inscribed angle has an intercepted arc. So an arc that is associated with that angle. So in this case, our intercepted arc, okay, is that arc AB. So there is a relationship between that angle and that arc. If you recall, pardon the drawing, you don't need to draw this because you have this in your notes elsewhere. This is a central angle, right? Central angle. Ooh, sorry guys. Terribly messy. What do you know about a central angle and its intercepted arc? They're the same. So if this is 60, this is 60. Do you think that's the same for an intercepted arc? No, it's not. If I draw, I'm sorry, for an inscribed angle, I said the wrong thing. If I draw this angle in, right? Same arc, 60-degree arc. Is that a 60-degree angle? No. Any guesses what you do to it? You cut it in half. Okay? So whatever this arc is, the angle, the inscribed angle, is going to be half as much, which is the inscribed angle theorem that you see right here. It says the measure of an inscribed angle is half the measure of the intercepted arc. Okay, so angle B is always going to be half of arc AC. So if this is 50, then angle B is what? This is not drawn to scale. Half of it, or 25. Okay, so inscribed angle, if it's on the circle, it's half as much. Let's take a look at this then. So it looks a little confusing when there's a bunch of lines everywhere, but I need you to, what's that movie? What's the baseball movie? Clear the Mechanism. I need you to clear the mechanism. What movie is that? It's that baseball movie.
Which baseball movie?
No. No. I just watched that one though. Such a good movie. Shoot. No, it's not Rookie of the Year. It's Kevin Costner. It's very old. You guys probably haven't seen it. It's a good movie though. You should watch it. No, it's not that one either. That's a great one too. There's so many good baseball movies. I'll look it up later. Yes, that's the one. Thank you. Google. Who doesn't love Google? For love of the game. Anyway, he says clear the mechanism. Like only see what you're supposed to see. Forget all the fans, forget all the stuff. So only see what you're supposed to see. So take a look at this. If I am looking at only this angle right now, okay, they're telling me that angle is B degrees. Do you see that angle's intercepted arc? It's 56, right? This arc right here is what that angle opens up to. So if that is 56, how does angle B relate to that? It's half of it. So angle B is going to be half of 56. So B is going to be 28 degrees. It's fun, right? Yeah. Okay, now look at A. Is there an angle that opens up to A degrees, that arc? Sort of. Right. There is not an angle that opens perfectly to A. However, there is an angle that opens up to a bigger arc, right? That's this right here. So if this is 52, how does this arc relate to it?
Angle's 48.
How'd you get that?
Because, well, if you multiply 52 by 2, you get that, and then you subtract it by 56.
Right.
And then you get A.
So the relationship is the angle is half as much as the arc, right? So I have to double the 52 to get my arc. Okay, so this arc is 104 degrees, but that arc uses A and the 56. So now you're going to say A plus 56 will equal that 104 degree arc. So take away the 56 and you get that A is 48 degrees. That's fun, right?
So much fun.
Yeah, I think so. Questions on that? Okay, let's look at example 2. This one looks a little bit different again. There's not quite as much overlap here. How many angles do you see? There's 4. You have a quadrilateral there, right? So there's 4 angles inside of that circle. Let's start with angle A. If you look at angle A right now, angle A is this angle. What arc is the intercepted arc for angle A? Yes, I think what you said. 2 people started talking at the same time. If you just connect those endpoints, right? That's that arc. It even looks like a baseball field, you guys. Look at that. It's a little wonky, but it looks like it. So we would say angle A is going to be half of what arc? 190, right? 190 put together. So half of 190 will be the measure of angle A, which is 95 degrees. Okay, so A is 95 degrees. So how do you find B? What's the intercepted arc for angle B? Right, here's angle B. Okay, that opens up to this arc. 64 and 90 put together. So angle B is half of 90 plus 64, or half of 154. Please don't distribute that. I mean, you can. I don't know why you would. Plug it into your calculator. 1/2 parentheses 90 plus 64. Let your calculator figure it out for you. Angle B is what then? Is what? 77, right? Half of 154. Okay, so angle B is 77 degrees. Now look at angle C. Angle C is here, which means our intercepted arc is all the purple right there. So we would say angle C is half of 106 plus 64. So half of 170. Angle C then is 85 degrees. Okay. So then last one, angle D. If you look here, D goes all here, right? D opens up to the 106 and the 100. So angle D is going to be half of 100 plus 106, so half of 206. Angle D is 103 degrees. Yes, sir.
So for the inscribed angles, if you know like the angles that say A and B, couldn't you just like subtract that from 180 and get the other angles? Because the opposite angles have 180.
Couldn't you? That's what we're going to talk about next. Copper. Yes, you're very intuitive.
On the homework, are we going to have to do all that?
I mean, what do you mean? Yes, you're gonna have to find the angles.
Can we just mentally take?
Oh, can you like plug it into your calculator? Show me, like if you show me on the first one, I don't care if you do the rest in your calculator, but I want to see that you knew what you were doing.
For each one, or just like.
Like if you have to find 4 angles the same exact way, do the first one by hand, like show me what you did, and then the rest of them I don't care if you do. I'm going to show you a shortcut right now that Luke actually just introduced to you, where you don't have to do all that work every time. But yeah, I want to see what you're doing. I just don't need to see it on every little detail maybe.
For D, couldn't you have just taken the sum of the 3 angles and subtracted that?
Yes, you could do that too. Yep. You guys are so smart. You just teach it for me. Okay. Oh, did I? Oh no, I did. I split them. Okay. So here are 3 corollaries to this theorem. Luke just showed you one. I'm going to show you 2 more. I'm going to show you all 3 right now. But here are just add-ons. Remember, a corollary is just an add-on to a theorem that we already know. So adding on to that, here's 2 extras plus the one that we just talked about. The first one says 2 inscribed angles that intercept the same arc. So if you look here, angle A opens up to the blue arc, and angle B opens up to the blue arc. If they open to the same arc, what's true of the angles? They're congruent. They will be congruent because their arcs are the same. Therefore, you cut those in half, you're going to get the same number, right? So if they open up to the same arc, they are congruent. That's the first one. Second one, an angle inscribed in a semicircle. So here's a semicircle, right? This is a diameter. So this is a semicircle. The angle that opens up to that will always be 90 degrees. Why? Because it's half of 180, right? Your semicircle is 180, so it will always be a right angle, okay? Always be 90 degrees if it opens up to a semicircle. So those are just good things to look for. You can always do the long process and solve them that way too, that's fine. The third one is the one we just talked about, the opposite angles of a quadrilateral inscribed. So if you have a quadrilateral inscribed in a circle, those angles are going to be supplementary. Okay, the opposite angles. So in other words, angle A plus angle C will equal 180, and angle B plus angle D will equal 180. Okay, the ones across from each other are always supplementary. And again, all 4 of them together will equal 360 because it's a quadrilateral. Okay? Questions on any of those 3? Okay. Then we're going to try a few, and then we're done. One really good thing to do on these types of problems is look for diameters, because diameters tell you a lot. So when you look at this example 3, do you see a diameter? Yes. Your diameter is here, right? Which means this is 180. Ugh, that was terrible, sorry. And this is also 180 degrees, okay? The question is, what is angle 1's measure? Well, if you look at angle 1, that goes diameter end to diameter end. So its arc is that 180. So what is angle 1? 90, okay? These numbers are just there to throw you off. Isn't that mean? That's so mean. But you don't use them. You don't need the 70, you don't need the 40. Angle 1 is going to be 90 degrees because it opens to a semicircle. Okay? Questions on that? All right, look at example 4. What do you see? You see anything that's helpful? This one's a little tricky because there's a lot of extra lines. What? Okay, we don't know if there's a diameter because they don't give you the center. If it's a diameter, they'll give you a point as the center. So it looks like a diameter, but we don't know it for sure. What is congruent, Bella?
The 2 angles.
Which 2?
38 and 2.
Right. They open to the same arc. 38 is here, Okay, so that opens to this arc, meaning that arc is 76, but you don't even need the arc because angle 2 also opens to that same arc. And we said if they open to the same arc, the angles are congruent. So angle 2 is going to be 38 degrees because this angle right here is 38 degrees. Okay, now if you want to double it, find the 76 and then cut it in half to find angle 2, you totally can. It's not wrong. You just don't need to. Okay, so that's up to you. Is that a hand up? No, I keep thinking you're raising your hand. Sorry. Questions on that? Okay, number 5 combines 2 of our things here. There's a quadrilateral, but there's also a diameter. If there's a diameter, which 2 angles do you know right off the bat? 1 and 3. What are they? 90. Because it opens to a diameter, this is 90. This one opens to a diameter also, so that is 90. So angle 1 is 90. Angle 3 is 90. How can you find angle 4?
You add 60 and 80 and then you divide it by 2.
Right, so angle 4 opens up here, right, which means its intercepted arc is the 60 and the 80. So angle 4 is half of that arc. Well, that arc is 60 plus 80. So 60 plus 80, that's 140. Cut that in half. So angle 4 is going to be 70 degrees. Okay, so what's angle 2? Supplementary to that. So angle 2 is going to be 180 minus that angle, right? So angle 2 is going to be 110 degrees, okay? Now you could have done that a longer way. You could have said, if this is 140, then what I'm left with over here is 360 minus 140, 210, and then cut that in half to find your angle, but you don't have to do all that work. Okay, if you just take the one across from it, it's got to be supplementary. Supplementary means they add up to 180, right? So 180 minus 70 will get you that 110. How'd we do? Questions? Do you love it as much as I do? So fun.